Hello guys, and welcome back to my YouTube channel. In the last video, we were talking about a brief introduction in functions and relations, codomains, domain and the range mappings. And in this video, we are going to be talking about types of functions, that is the injective, the surjective and the bijective function. Okay, we are going to start with the first, which is the injective function. We're going to start with the injective function. And another name for this type of function is the one-to-one function. Another name is the one-to-one function. Now let's have two sets. Set A, which has the elements 1, 2, and 3. And we have a set. This maps to another set B, which has the elements A, B, and C. So this set A maps to set B. So from the arrow showing, we're going to have that 1 maps to A, 2 maps to B, 3 maps to C. So as we can see, each element in set A maps to each element in set B. So for example, 1 has only one element in set B in which it maps to. So this is a one-to-one function. 1 to 1. 1 maps to A only, 2 maps to B only, and 3 maps to C. Okay, let's take an example. If we have f of x giving us x plus 3 with a domain, let's say 1, 2, and 3. So if we want to get the output, remember from the last video, we take the first value 1, we substitute it, have f of 1 is equals to, we substitute into this our equation, we have 1 plus 3, which gives you 4. We take the next value, f of 2, we substitute it into the equation, 2 plus 3, we have 5. We take the next value, 3, we substitute it, 3 plus 3, and we have 6. And as you see, 1 maps to 4, 2 maps to 5, and 3 maps to 6. So each input has a unique output. That means it is a one-to-one function. But what if we have a case where it is not injective? How would we know? Let's take another example and see how that goes. Okay, if we have another example, let's say f of x equal to x squared, and we have, let me say, the same domain above, 1, 2, 3. So let's take 1. If we have f of 1, okay, now let me take another case. This one is still going to be injective. Okay, let's say if we have 2 and minus 2. Okay, so now let me take the first value 2. If we have f of 2 equal to 2 squared, this will definitely give you 4. If we take the next value, we have f of minus 2, as minus 2 squared, this will still give you 4. You can even care to add 1 and minus 1. Okay, let's just do that one. If you have f of 1, it's going to give you 1 squared, which is 1. And if we have f of minus 1, it's going to give you minus 1 squared, which is still 1. So in this case, we see that 2 maps to 4 and minus 2 also maps to 4, and this is not a one-to-one function. This is not a one-to-one relation because they do not have a unique output. Each input has the same output. They don't have unique outputs. Even in this case, for 1 and minus 1, 1 maps to 1. And minus 1 also maps to 1. And they don't have a unique output. And so, this is not a one-to-one relation. It's not injective. So here we can say that it is not injective in this case. Okay, now let's take a different case. If we have a function x equal to, let's say, x minus 2, and it is said that determine if this function is injective. Okay, another way we can say f of x1 should be equal to f of x2. So we are going to take the first case, f of x1. F of x1, we simply substitute x1 in this equation. So it's going to be simply x1 minus 2. The second case, f of x2, will also be simply x2 minus 2. Now we equate them. So they should be equal. So we equate them. x1 minus 2 equal to x2 minus 2. So if we say x1 minus 2, take this 2 this other way, is going to be plus 2 equal to x2. From there we see that x1 is equal to x2. So from here, this is the same as x1 equal to x2. So we have ended up with the same thing. So that tells you that this equation that we had is injective. Okay, that is simply all for injective functions. Now let's go to the second case, that is surjective functions. Another name for this also is an onto function. So that is another name. Remember, another name for injective function is one-to-one function. But another name for a surjective function is an on. Okay, when we are talking about a surjective function, there is one thing we need to put in our mind. We need to know that the range here should be equal to the codomain. The range should be equal to the codomain. This is the main part of a surjective function. This is what we need to know when we are talking about a surjective function. The range should be equal to the codomain. Okay, let's take an example. Let's say we have 1, 2, 3, 4. This is our set A. And we have another set B having 5, 6, 7, and 8. Okay, let me do a rough mapping here. Okay, okay, let me just do some quick adjustments. Okay, so we have this. Let me just say, okay, so for this to be injective, for it to be injective, every element, like every an image, this is an image should have an ancestor in the domain. An image in the codomain should have an ancestor in the domain. Here, let's take this 5. 5 has an ancestor. It has 1 and it has 2, but it has an ancestor. 6 has 4. 7 has 3. So here, this is surjective. Okay, let's take a case where it is not surjective. Let's say we have the same 1, 2, 3, and 4. And let's say we have 5, 6, 7. Okay, yeah. If okay, let's just do a quick mapping. Let me do a quick mapping. Okay. Okay, sorry. Let's come back to this case here. Okay, this 8 is supposed to match somewhere because each element in the codomain should have an ancestor in the domain. So this should be surjective. So here, this should not be surjective because each element in the codomain, every element does not have an ancestor in the domain. 8. 8 does not have an ancestor in the domain. It is not mapped to anything in the domain. This is the domain and this is the codomain. 8 is not mapped to anything in the domain. So this should not be considered as surjective. So this is not surjective. Okay, let's take another case where it is both surjective and injective. Let's have x1, x2, x3 for this set, and let's have another one. Sorry, y1, y2, and y3. So they are mapped. Let me do their mapping. So in this case, it is both surjective and injective. So you're going to be asking why. Why is it both surjective and injective? Firstly, injective, I said for injective, each member in the domain should have a unique element in the codomain. So each is mapped differently. X1 is mapped to only Y1, X2 is mapped to only Y2, X3 is mapped to only Y3. So X1 has a unique output, X2 has a unique output, and X3 has a unique output. So let's go to subjectivity. For subjectivity, I said each member in the codomain should have an ancestor in the domain. So each member should at least have an ancestor in the domain. So as you can see here, y1 is mapped to x1, y2 is mapped to x2, and y3 is mapped to x3. So we can see that each member in the codomain is at least mapped to something in the domain. Okay, now let's take a brief okay, let's say f of x equal to x plus 5, and let us determine whether this function is injective or surjective. Let's just determine whether it is surjective. Okay, remember what I said above? I said the range must be equal to the codomain for that function to be surjective. So for the function to be surjective, the range should be equal to the. Let us remember that the codomain, from my previous video, I said that the codomain is a set of possible outputs, of all possible outputs, and all possible outputs can be real numbers or are real numbers. So our codomain is a set of real numbers. This is our codomain in this case. Now, to find the range, to find our range, let's just have a domain of 1, 2, and 3. Now let's start with f of 1. We have 1 plus 5, which is equal to 6. We have f of 2, which is 2 plus 5, which is equal to 7. And we have f of 3, which is 3 plus 5, which is equal to 8. So it ranges now 6, 7, and 8. And so 6, 7, and 8, they are real numbers. So it is surjective. Now let us go to the third case, which is bijective, which is in bijectivity, we need to know that for a function to be bijective, it has to be both injective and surjective. So when given a function, when they say determine if it is bijective, we need to know that for bijectivity, it has to be both injective and surjective. So we are going to determine injectivity and then we determine surjectivity when given a function. Let's take an example. Let's say f of x is equal to x plus 1 and we are to determine whether it is bijective. Firstly, we'll test for injectivity. So firstly, we need to determine whether the function is injective or not. So remember I said for injectivity, f of x1 should be equal to f of x2. And this is also the same as x1 equal to x2. So now from here we're going to substitute it into the equation. So we're going to have x1 plus 1 equal to x2 plus 1. So taking this one this way, we're going to have x1 plus 1 minus 1 equal to x2, and this equates to 0. So we're going to have x1 equal to x2. So here we can say that it is injective. And then secondly, for surjectivity, remember I said the range should be equal to the codomain. And the codomain equal to a set of real numbers, a set of all positive outputs, which are the real numbers. So now we are going to find the range. To find the range, we need to look for the inverse of this function, and this takes us to inverses of functions. Okay, to look for the inverse of f of x equal to x plus 1, the inverse of this function can also be, we can also write it as f to the minus 1. That is also that is what we can write for the inverse of a function. So we need to look for, let me just erase this. We need to look for the inverse of that function. To look for the inverse of this function, we're going to take a certain y and equate it to x plus 1. Okay, from here we are going to make x the subject of the formula. So we're going to have x equal to y minus 1. From here we can see that our range is just a set of real numbers. So x is just an element of a set of real numbers. Okay, why do I say that x is just an element of a set of real numbers? This is our inverse. We have concluded that f inverse of x is equal to, we just change this y to our x minus 1. This function does not have a denominator. It has only a numerator. And so, since there is no denominator, we conclude that x is just an element of real numbers. And so, from here, x is an element of real numbers and our codomain is a set of real numbers. So here we can say that the range equal to, the range is the range is x element of real numbers and our codomain is the same. From here we said our codomain is an element of real numbers, and so since the range is also an element of real numbers, then we can say it is surjective. So therefore it is surjective, and above we concluded that this equation was injective, and here we have also said that it is surjective. And so from above I earlier said that for a bijective function it should be both injective and surjective. So we can conclude that the function is bijective. Okay guys, thanks for watching my video, and I'll see you guys in the next video.